Hello there, Gamal Basali here. Today I'll be explaining about an implementation of a tree data structure. So here in my Java project, I have created three classes, which are the main.java, mat3.java, and stack.java. So I have um, get some help from another type of data structure, which is the stack. So this stack is mainly going to be having a purpose of converting an infix mathematical expression into a prefix. Because why prefix? Prefix is kind of bit easy to insert into our tree, so that's why I implemented also the stack Java here. So here in my main method, I have instantiated the main.java, which is this one, to convert the infix, and here I have created a tree. So let's take a look at I have a mat3 class node here. So here is the informations about a node. It has a value, and it has a child pointer from child to the left and child on the right. So because in this tree, this is a mathematical expression, which is also a binary tree, which an a node can only have two, one or more, one or more. I mean, one or more nodes or child nodes. So here, we're going to start with the main. So here have created a tree. So this is where my adding of nodes happen. So here I have created a add node method, which has a character parameter for the label. Sorry. And here I created a mat3 node to be the new node, and then we're going to insert, and here it is the constructors that do its job. So first thing first, if the root is equal to null, and because basically a tree has always a root, and here we're going to check if the root is still a null, because this is just the first um, addition of a node into our tree. So once there is already a node in our inside our tree, the root will not be null anymore. Therefore, we'll be going to express the new algorithm in the else statement. So I created a mat3 node as the current node. So basically the current node, or the focus node that we need to take uh, point of. And here is another tree node, which is the parent node. So this is going to be the parent node for the future nodes that we're going to um, visit. So first, parent node is assigned to the current node, which is the root. So basically we need to start from the root until we reach into the leaves, like that. So first we have a statement if set label prio. Here the labels or the nodes that I am inserting, I first assign some priority. So basically the higher priority, it will be located in the upper portion of our tree. So first, set node label. So this is just the same with the node label and the label. So set node label. So this is basically the label for the node that is already in our tree. And next is the label priority, will be the to be added node. So as you can see, all the operators has a value of 2, which is higher than 1. So basically, if a label is a character that is not an operator, it will basically get a priority of 1. Therefore, we're going to check if the if the node that we're going to insert is equal to the priority of the current node. Then we're going to assign the current node to the left node. Therefore, this is basically the left child of the parent node that we assigned earlier. So here in the if, to make sure that the current node is not equal the left child of the parent child. Therefore, as it is being executed, the parent node that left will be our we're going to throw or insert the new node, and then we're going to return to break the while loop. So next we're going to talk about is this. There's a case that we're going to insert a new node that is basically the priority is not equal to the to the node priority, because if we try to look, the root should be an what do you call this, an operator, so it should be a higher priority. But in this case, if it is a just an operand, so it becomes a letter it becomes a lower priority. So I have here a current that node that left. If it is null, then we're going to insert the new node. And then in the third if statement, this is basically if the what do you call this, if the node that is we're going to insert has the location where a node has a left child, which in case has a label of let's say it has a child operand, so the child of this current node will be an operand. So therefore, if it is equal to the label prio that we're going to add, then we're going to insert the new label to the right. So if there is already an operand next at the left side of left child of a node, then as long as we are going to add another one, then basically we need to insert the right node first of the very last node that we inserted. So next, this if statement is intended for the case that where we have already input two children of the very last node that we inserted. Then the next node that we're going to insert should be the right child of the upper node where we inserted the last node. So that's basically the intention of this fourth if statement. So here there are some methods that we are going to use later on. So let's try to check the program if it really works well. So here I've already input some what do you call this, an expression. So we're going to try it again if that's really works. So 8 minus 2 times let's say 3 times 4. So basically this is our the very right node, I mean the root of our tree, and this will basically its left child, and this will basically the left child of the plus, and then this will be its child, and then the right child of the plus symbol is 3, and the right child of the multiplication is 4. So how did that happen? So first the So here we can take a look at, I have created a for loop here so that we can insert each of the character inside a string. So here in the for loop, I initialized I is equal to 0, and the condition is I is less than the expression string length. So therefore it should be end into the last string of the string. So here tree that add node, therefore each of the the character inside this expression string will be validated, so that each of that string will be added into our tree. So first, the multiplication sign. So as you can see, there's there's nothing, there's no node in our tree, so we have a multiplication here. So therefore this will fall in this if statement. In the second iteration, the plus will fall into, oh sorry, it was where is add node? Here. So basically it will the multiplication sign will be basically fall here, and then the plus sign will basically fall in the else statement. So if they are equal, therefore their priority is equal, then that next node will be inserted to the left child of the root. And here in the third sign, which is the minus, so it is just the same, it will fall into the else statement, and the rest of these what do you call this nodes will fall in this else statement. So let's try and see how did I outputted the pre-order the pre-ordered transverse of a tree. So here I created this method, which inside of this is a recursive method, so which calls itself as long as the node is not equal to null. So basically it will start from the left, and then as long as the left child will have a null value, then this first recursive function or recursive method will not be anymore executed. Then the next one will be the right side. Therefore every right child of a node will be printed. So basically the right nodes will basically what you call this will appear in the last part of this outputs. So there are only two right nodes that right child that we have, which is the 3 and 4. So let's try to see if how did we arrive this value. So let's try to check. So first we're going to do a depth first search, which in here. So basically I created a, instead of transversing the actual tree node, I just created or let's say I just took some help in our stack in which we are going to throw or push all the nodes that we have inside our tree. So basically the very first element inside of that stack will be the root, and the one on the top will be the very last child in a form of a pre-order. So that is how it actually happens. And here we're going to check if that actually works. So first, we have created an operator stack, an operand stack, and the stack for the values. So first, let's take a look at this. As what I said earlier, we need to push all the nodes that we have in our what you call this tree. Therefore, the for loop inside this argument is just the same with the main one. And then if check if it is in operator, if that so this is basically not anymore the infix form of the expression that the user inputs. Therefore, it is already a converted one, because inside the main method we have assigned the expression to the converted expression, which is the the prefix expression. So back to the first search. So here we have, if it is an operator, so this method is a Boolean method that returns a true value if a character is an operator. So that will basically be going to be pushed or inserted to the operator stack. And then the else statement, we have here an operand that push, which is if this is not being satisfied, therefore that character is not an operator, therefore it is an operand, and then we're going to insert it to the stack inside the while loop. So intention of this while loop is to pop all the operator nodes, so that we can perform an arithmetic expression, or so that we can get the value of this arithmetic expression. So first, the operator OP code will be assigned to the pop operator, and then the right for the operand and left for the also for the operand. So here I have a result which is a float float type. So therefore we have an evaluate method, which right here that has three parameters, which are the float right and float left. So basically the parameters that we are going to pass is naturally an what do you call this, a string type. So we need to parse it into float. See, we need to parse it in float. So we have here 3 float. So as you can see, this is just the OP code is a string. So therefore I make use of the char attribute so that we can actually get the character value of that string. And here we have an attribute of float that value of to determine what is the value of that character in float type. So here it will be passed right here, so I'll be not anymore talking about this 2 types. So here we have an operand. So the operand will be if that character is each of this will be the return value. So it basically computes the result for every pop of an operator code. So that's basically the for the popping of the operator. So as long as the operator, all the operator is being popped, basically there will be one more operand that will be left in our operand stack. Therefore, we need to pop it so that we can know the value of what is that element possess. And then, as you can see, I have a value, also a value, what do you call this, stack, value stack. And then every result is going to be pushed into that stack, which is also a string stack. And then an operand that push, so that we can go back the put back the result into the operand once there is an operator that is being popped. So it will be partnered with two operand. So this basically here the while values that is empty. This is the, what do you call this, the condition, and here we have the temp equals values that pop. Therefore, the very what do you call this, the very last value that we are going to pop in the what do you call this, this will basically the top value. So the intention of this value that push is just to input the for every operator only, and this will be basically the very final answer that we need to have, and that final value will be the value of our root node. And as you can see, I have here a method that is add value float, and it has a parameter of float. So here, as you can see, I created another math tree node. Therefore, it has no the constructor has no argument. And here, if root that value, which is the root, is equal to 0, which is basically all of the root values are equivalent to 0, but the only thing that we're going to be pointing on is the root value. Therefore, the root, that value will be equal to the value that is being passed in the parameter of this add value inside this while loop. So that's constitutes the explanation of this code, and I don't need to explain anymore about this basic stuff. So this is already an explanatory. So here we're going to validate if that is this expression is really true. So 8 minus 2 is 6 plus 3, 9 times 4 is 24. So 8 minus 2 plus 3, 6 plus. So let's try again another example. Say we have 3 plus 4 minus 5 times 2. So here we can see that so thank you for watching. Gamel Basali here. Thank you.